Every tap on your phone triggers an API call, a digital message that travels the globe, hits a server, and returns a response. It's a process that happens in milliseconds, so fast and seamless that we rarely stop to think about what's happening behind the scenes. But each of these invisible interactions is powered by a vast network of machines, cables, and data centers working tirelessly to keep our digital world running. It feels instant and clean, but each call releases a tiny puff of carbon dioxide. Multiply that by the millions of apps and billions of users, and the environmental impact quickly adds up. Even the smallest digital action leaves a trace in the physical world. Billions of users making trillions of requests daily create a flood of emissions. Our collective digital habits are shaping a new kind of pollution, one that's largely invisible, but just as real as smog in the air. Data centers powering these requests consume more electricity than some countries, much of it from fossil fuels. These facilities run 24/7, requiring constant cooling and maintenance, and their energy demands are only growing as our appetite for digital services increases. The code we write has real-world environmental consequences. Every inefficient algorithm, every unnecessary request, and every poorly optimized process adds to the load on our infrastructure and to our carbon footprint. For years, we optimized for speed and cost, but ignored environmental impact. Now, it's time to add sustainability to our list of priorities and rethink how we build and maintain our systems. Inefficient code isn't just expensive, it's dirty, wasting electricity and hardware and growing our digital carbon footprint. The more resources we use, the more pollution we create, often without realizing it. The same optimizations that save money also make systems greener. By streamlining our code and infrastructure, we can reduce both costs and emissions, creating a win-win for business and the planet. Thinking about code's carbon footprint is practical engineering, not just a feel-good exercise. It's about making smart, responsible choices that benefit everyone: users, companies, and the environment. Efficient systems mean fewer servers, lower bills, and less carbon. When we design with efficiency in mind, we build infrastructure that's both powerful and sustainable. We can build robust, scalable, cost-effective, and sustainable systems. The technology exists. It's up to us to use it wisely and intentionally. The secret: write better, more efficient code. Every line matters, and small improvements can have a big impact at scale. This guide is for back-end engineers and IT managers. If you're responsible for building or maintaining back-end systems, you have the power to make a difference. We'll focus on concrete, actionable steps to reduce your software's environmental impact. You'll learn how to spot inefficiencies and address them head-on. We'll break the problem into 3 areas: hardware efficiency, network efficiency, and energy efficiency. Each area offers unique opportunities for improvement. For each, we'll identify common sources of waste, like zombie servers and bloated data payloads. These hidden inefficiencies are often overlooked, but they add up quickly. Then we'll provide simple solutions you can implement. These aren't just theoretical ideas, they're practical steps you can start using today. Use this as your checklist for building cleaner, cheaper, and more sustainable back-end systems. Together, we can make our digital world greener, one API call at a time. To build greener software, we need to look beyond just the code we write. We must understand where digital waste comes from and how our everyday decisions as developers contribute to it. Think of it in 3 categories: hardware efficiency, network efficiency, and energy efficiency. Each plays a unique role in the environmental impact of our software. Hardware efficiency is about maximizing the work done per server, avoiding idle machines that still draw power, even when they're not being used to their full potential. Imagine a data center full of servers running 24/7, many barely used. This scenario is more common than you might think, and it leads to significant energy waste. Our goal is to maximize server utilization and eliminate waste, ensuring every watt of power is put to good use. Network efficiency is about the data we send and how we send it. Every byte traveling the internet uses energy, through routers, switches, and cables. The infrastructure that supports our digital world is vast and energy-hungry. Sending large, uncompressed payloads is wasteful. Millions of requests multiply this waste. Even small inefficiencies add up at scale. Trimming digital fat from data transfers by compressing files and optimizing payloads makes systems leaner and greener, reducing the burden on global networks. Energy efficiency focuses on the code itself and how it runs on the hardware. Two algorithms can do the same job, but one might use 10 times more CPU cycles, leading to much higher energy consumption. Inefficient code forces processors to work harder, consuming more electricity and generating more heat, which in turn requires more cooling. Our programming choices have a direct environmental impact, shaping how much energy our applications demand from the planet. Choosing the right data structures and optimizing logic reduces energy use, making our software more sustainable in the long run. These aren't just academic exercises, they're essential for green computing and for building a future where technology and sustainability go hand in hand. By focusing on these three pillars, we can make our software a model of efficiency, setting new standards for the industry. Let's dive into practical steps for each and see how we can all contribute to a greener digital world. Zombie servers, idle virtual machines or containers left running, are more common than you might think in today's data centers. These silent killers quietly drain your budget and waste energy, harming both your bottom line and the environment. To fight back, start by thoroughly auditing your cloud resources. Tag every server, every instance, and ask what each one is for. If you find resources that aren't needed, don't hesitate to shut them down or decommission them entirely. Many organizations are surprised to discover that up to 30% of their infrastructure sits idle, doing nothing useful. Schedule regular downtime for non-production servers, and automate shutdowns during nights and weekends to maximize savings. For production workloads, use aggressive auto-scaling policies to match real-time demand, scaling down to 0 whenever possible, so you're never paying for unused capacity. By following these steps, you can cut energy use and operational costs by over 80% for some servers, freeing up resources for innovation. Slaying zombie servers is one of the simplest, yet most impactful changes you can make to your IT environment. Make it a regular habit to review, optimize, and keep your infrastructure lean, efficient, and green for the future. Every back-end response is like shipping a package. The smaller, the better. Switch from verbose formats like JSON to compact binary formats like protocol buffers, to shrink payloads by up to 80%. Only send the data the client needs. Use data transfer objects or GraphQL to avoid bloated endpoints. Enable compression, gzip, broadly on your servers to further reduce data size. These changes speed up user experience, cut network energy use, and save money. Trimming digital fat is a win for performance and the planet. Review your APIs and data formats regularly. Make every byte count. Inefficient code is a hidden energy drain. Choosing the right algorithms and data structures, like using hash maps instead of lists, can save massive CPU time. Process data in streams, not all at once, to keep memory use low. Every CPU cycle saved is energy saved, multiplied across millions of requests. Cultivate mechanical sympathy. Understand how your code runs on hardware. Write cache-friendly, efficient code that respects machine limitations. Clean code isn't just fast, it's green. Polling, clients repeatedly asking servers for updates, is a massive source of waste. Thousands of useless requests heat up CPUs and networks for no reason. The solution: event-driven architecture. Let the server notify the client when there's an update, using WebSockets, server-sent events, or message queues. This shift eliminates wasted requests, saving energy and bandwidth. Moving from polling to events is a fundamental architectural improvement. It's more efficient, scalable, and sustainable. Rethink your update patterns. Ditch polling for good. Oversized thread pools in Java and Python apps waste memory and CPU. Default settings are rarely optimal. Too many threads create overhead, too few cause delays. For I/O-bound apps, use smaller thread pools and asynchronous frameworks like Project Reactor or Gevent. Configure thread and worker counts based on your workload, not defaults. In Java, set thread pool sizes deliberately. In Python, use async workers for concurrency. Matching your concurrency model to your workload slashes waste. Review and tune your thread pools regularly. Efficient concurrency means greener, faster servers. AI is driving a new wave of energy consumption. Training large models can use as much power as hundreds of homes. Inference or running these models adds ongoing costs. As AI becomes ubiquitous, its energy demand could erase past efficiency gains. We must demand and develop more energy-efficient AI models, hardware, and frameworks. Techniques like model quantization, pruning, and task-specific small models are key. Treat AI compute as precious, not infinite. The journey to greener code is ongoing. Audit, question, and improve continuously. The choices we make today shape a sustainable digital future.